Let's take that pseudocode and convert it into Shplait code. Here I've got the unify function with tau1 and tau2 as the arguments. And then here, this is the real code, so I've got the expression that I use to complain if these two types don't unify. It's easiest to handle that second batch of cases first, because there we can consider all the possible shapes of tau2. If it's a type variable, as we had in the pseudocode, we just swap the arguments and try unify again. Otherwise, tau2 must be an int t, a bool t, or an arrow t. If it's an int t, then tau1 had better be an int t. Remember, tau1 is not a type variable, so either it's literally int t or it doesn't match. Same for the bool case, either it's literally bool or it doesn't match. If it doesn't match, we complain with the type error. Finally, if tau2 is an arrow, then tau1 needs to be an arrow as well, and we unify the argument and results part. Otherwise, if tau1's not an arrow, then we have a type error. So that was the second batch. All the first batch is in this var t case. So let's start filling that out. The first thing we considered, remember, is whether this tau1 as a type variable, t, whether it's already unified, whether it's already assigned to something. And if it is already assigned to something, then we can forget about t1 and just look at that tau3 that's inside there, again recurring with unify. So the remaining interesting case is where this type variable has not been equated to anything so far. We're going to equate it to t2. But before we install that equation, first we resolve tau2 to get some simplified version tau3, and we check, is tau1 exactly tau3 already? That means we passed in the same type variable and we're trying to unify them. We don't want to install an equivalence of that type variable to itself, but we do want to succeed, so we just return void. Notice the three equal signs here. I'm not saying does tau1 look the same as tau3? I mean, are they actually the same object? That's what the three equal signs do there. Do they have the same box? And if I assign to one of the boxes, will I see that assignment on the other side? Right. So if they're the same, we're done. Otherwise, if t1 appears somewhere in t3 without being exactly a t1 over here as t3, if the occurs check fails, then we have to raise a type error. But otherwise, they're not already the same, and the occurs check doesn't say that t1 is somewhere inside of t3, so we can assign to that box to say, from now on, t1 here is going to be treated the same as t3. So we filled in all our dots, just not all at the slide at the same time, and that's the complete implementation of unify, but we still haven't implemented resolve or occurs, and those look like this. Resolve's job is just to simplify an immediate type variable. So if t is a type variable, we check whether the type variable has been assigned to any other type. If not, we can't simplify and we just return t directly. But if we have been simplified, if it has been equated, then we can simplify by at least returning t2, but maybe t2 is also a type variable that's equated to something, so we keep resolving that until we get down to either a type variable that is not assigned or a non-type variable type. It turns out that resolve does not need to look inside of arrow types, say, because its only job is to simplify an immediate type variable. Occurs, on the other hand, does need to look inside of arrow types. We're checking whether r appears anywhere inside of t. And if t is just int or bool, then r does not appear there. If t is an arrow type, then we need to check the argument, and we need to check the result type to see if r is anywhere in there. If t is a type variable, then if r is in fact exactly t, we have found it, it does occur somewhere. But if r is not exactly t, well, then we need to check whether t is assigned to anything. And if it is, then we recur with an occurs check on r, the same r, we're still looking for the same r, but whatever the type variable t was assigned to, some tau2 here. So with those two helper functions, unify is complete.